Hello, good morning, good afternoon, good evening to you out there, wherever you are in the world, depending on your time. So, this is Samuel and I can welcome you to this channel. So, in this video, we're looking at the concept of Archimedes principle. So, in our last lesson, we looked at the concept of upthrust, and I explained what upthrust is. Upthrust is very important when we are dealing with density, when we are dealing with floating bodies such as ships, balloons, and the rest, things that float. So it's critical you understand the concept of upthrust. So before I move ahead with the lesson, in case you are not subscribed to this channel, I will implore you to go ahead and hit the subscribe button, and also hit the like button and click on the bell icon and set it to all, so that you will always be notified whenever I upload a new video. Okay, so before we go ahead with this lesson, I just want to say something about upthrust which I did not mention in the previous video. What are the factors that influence upthrust? There are two things that actually influences upthrust. One is the density of the fluid in which the body is submerged. The higher the density of that fluid, the more will be the upthrust on that body, the force pushing the body out of the fluid, the more will be the upthrust. If the density of the fluid is higher, then the upthrust on that body is going to be high. And another thing is the volume of the object, that is the mass. When you have more volume of that object so much, the upthrust on it is going to be greater. So those are the two factors that actually influences upthrust. So we move to our topic, our lesson for today. We are looking at Archimedes principle. What is Archimedes principle? Archimedes principle states that when a body is partially or completely immersed or submerged in a fluid, which may be a liquid or gas, it experiences an upthrust which is equal to the weight of the fluid that is displaced. So definitely, when a fluid is on its own and a body is submerged, that fluid will be displaced. It's going to be displaced. Okay, and the volume of the fluid displaced depends on the volume of the body that enters into the fluid. If the entire body that is being immersed, if the body enters completely, is completely submerged, then it will displace the volume of fluid equal to its volume. If half of it is submerged, it will displace half of its volume. If a quarter is submerged, it will also display a quarter. Okay, so this is Archimedes principle on the board. Archimedes principle states that when a body is partially or completely immersed or submerged in a fluid, it will experience an upthrust which is equal to the weight of fluid displaced, which is equal to what? The weight of fluid displaced. So let me quickly illustrate this definition with a diagram. Let's assume this is a container, a beaker containing water at this level. And I have maybe a metal. I now let down the metal block. So when I drop this metal block into the beaker of water, what is going to happen is that it will displace water. So the water will not be at this level anymore, it will rise. The water level is going to go up. By the time I immerse this metal block into the beaker of water, so the water level is going to rise. So we had an initial volume here. Let's assume that this was 10 centimeter cube, and this is now 15 centimeter cube. The new level is now 15 centimeter cube. Okay, so this block has actually displaced water. So the volume of water displaced is equals to 15 minus 10, which is 5 centimeter. So now the upthrust experienced by this block will be equal to the weight of that 5 centimeter cubic centimeter of water that has been displaced. So volume of water displaced is 15 minus 10, which is 5 centimeter cube. Then once you convert this 5 centimeter cube to weight, then so weight of displaced water, this, if you use this formula, density times volume times acceleration due to gravity, so you have this is the volume of water here, 5 cubic centimeter, then acceleration due to gravity is about 9.8 something, 9.86 meters per second square. Then density of water is 1000 kilogram per meter cube. You are going to convert this one to cubic meters. Then with that you can get the weight of fluid that is displaced. When you calculate the weight of the fluid that is displaced, that gives you the upthrust acting on that block. Okay, so that is just Archimedes principle. Archimedes principle tells you that the upthrust is equals to the weight of fluid that is displaced. Archimedes principle tells that the upthrust is equals to the weight of fluid that is what? That is displaced. Okay. So we're going to take some calculation right now. So the calculation we solved in our last lesson. So we're going to still look at that and calculate some other parameters. Okay. So over here we have a question. The question is a solid weighs 147 Newton in air and 98 Newton when totally immersed in water. What is its density? G is equals to 9.8 meters per second square. So we looked at this question, although we didn't solve this aspect because then we're not treated at Archimedes principle. We calculated the upthrust, then we looked at the loss in weight, the apparent loss in weight, and so on. That was what we did in the previous lesson. So over here right now, we are going to calculate the density of this solid. We need to get the density of this solid. They give us the mass of the solid in air, and you know that from density is equals to mass over volume. You know the mass in air, but you don't know the volume of this solid. The volume is not known. If you can find the volume, then definitely you can get its density. So how do you find the volume? Now they told us that the solid is totally immersed in water. That means the entire volume of that solid is completely submerged, immersed in water. So if the entire volume is submerged in water, that means this body now is going to displace an amount of water equal to its volume. So if we can calculate the volume of displaced water, then definitely our problem is solved. We can then get the volume. That will be equal, the volume of displaced water which we calculate is equal to the volume of this solid. So volume of solid, since the solid is completely immersed in water, the volume of the solid is equal to the volume of displaced water. That is it. We just need to calculate the volume of displaced water, and we can get this from the upthrust. We can calculate the volume of displaced water from the what? From the upthrust. So upthrust is actually equals to the weight in air minus the weight in water. So it weighs 147 Newton in air. In water it weighs 98. So 148 minus 98 gives us this is 9, then this is 49 Newton. So this is the upthrust. This is the upthrust acting on that solid. And from Archimedes principle tells you that the upthrust is equal to the weight of fluid that is displaced. So the weight of water that is displaced is equals to 49 Newton. So the upthrust is equal to the weight of, in this case the fluid is water, so the weight of water displaced is equals to 49 Newton. Equals to 49 Newton, equals to the upthrust from Archimedes principle, which in this case now the upthrust is 49 Newton. This is the weight of water that is what? That is displaced. So we have the weight of water that is displaced. So all we need to do is just to calculate the volume of water that is displaced from the weight of water that is displaced. So right now, density is equals to mass over volume. So from here, density times volume is equals to mass. So the mass of water that is displaced is given by the density of water times the volume of water that is displaced. Okay? So the density of water times the volume of water gives you the mass of water that is displaced. And how do you get the weight of water? Once you have weight is equals to mass times acceleration due to gravity, mg. Weight is equals to mass times acceleration due to gravity. So to get the weight of water displaced, you are going to multiply this with the mass of water displaced by g. So this is the same thing as density of water times volume of water displaced times acceleration to gravity g. This gives you the weight of water that is displaced. So from here now, you can go ahead and density of water, you have it. Volume of water is what we are looking for. And g is given, the constant. Weight of water is equal to the upthrust, 49 Newton, is available. So let's go ahead and complete the solving. So density of water is also a constant. Density of water is approximately 1000. Density of water is approximately 1000 kilogram per cubic meters. Okay, density of water is approximately 1000 cubic meters. So let's substitute the values into here. Density of water is 1000 kilogram per cubic meters. Volume of water is what we're looking for, we don't know. Acceleration due to gravity is 9.8 meters per second square. The weight of water is what? Weight of water displaced is 49 Newton. So from here now, we can now solve for the volume of water. This is going to give us that the volume of water is equals to 49 Newton all over 1000 kilogram per cubic meter times 9.8 meters per second square. So let's punch our calculator. We're going to punch our calculator right now to get the volume of water that is displaced. So let me just get my calculator and do that. So on punching my calculator, I arrive at 0.005 cubic meters. So this is the volume of water displaced. So the volume of water displaced is equal to the volume of the solid. Since the solid was completely immersed in water, so this is the volume of water that was displaced is equal to the volume of the solid that was immersed. So this is the volume of that body. So from there we can actually calculate its density now. So we had its mass, we had the weight of that solid in air. So from there, the weight in air was 147 Newton. So weight is equals to mass times G. Okay, so since the weight is 147, so we can calculate the mass. G is 9.8. So from here we can actually get the mass of that. Solid. Okay, so the mass is going to be 147 divided by 9.8. This is the mass of the body. So since we know the mass of the body, the mass is 147 divided by 9.8. Then to get the density is equal to mass over volume. This is the mass. Then the volume, we've calculated the volume to be 0.005 cubic meters. So this is in kilogram. So I could have just gotten a value for here, for this one, for the mass, and then divide by the volume, but I don't want to punch things over and over again. So we have that the mass is 147 divided by 9.8. Then now, while the volume is 0.05, so let me punch my calculator to get the value. We have 147 divided by 9.8. That gives us 15. So the mass of this body is actually 15 kilogram. So we have 15 kg, 15 kilogram divided by 0.05 cubic meters. So let's divide that. So this gives us 3000 kilogram per cubic meters. So the density of that solid is 3000 kilogram per cubic meters. So the question asks us to calculate the density of that solid. It wasn't given. They gave us the weight in air. From the weight in air, we can calculate the mass in air, knowing that weight is equals to W. The weight is equals to mg. Weight is equals to mass times acceleration due to gravity. We have the weight. Acceleration due to gravity is 9.8 meters per second. So with that, we can weight divided by acceleration due to gravity gives us the mass, which we did here, which gave us 15 kilogram. So they gave us the weight when totally immersed in water. From that, we'll be able to calculate the upthrust. And upthrust from Archimedes principle, we are told that upthrust is equals to the weight of fluid displaced. So from Archimedes principle, upthrust is equals to the weight of water that was displaced by this solid. Okay, so the weight of the solid of water that was displaced, which we calculated from here. We combine the upthrust now, 49 Newton. The weight of water displaced is also equals to the upthrust, 49 Newton. So we now converted weight. We knew that mass is equals to, density is equals to mass over volume. Density times volume gives you mass. So, and we know that mass times g gives you weight. Now we have the weight as 49. So we have the weight as 49 Newton. We have g as 9.8. So 49 Newton divided by 9.8 will give us the mass of water. Gives us the mass of water, even though we didn't calculate the mass of water directly. Okay, so from there, yeah, we have density of water. We don't have the volume of water, but we can calculate the mass of water from the weight. So density of water times volume of water gives you mass of water. Now density of water times volume of water times g gives you the weight of water, which was actually given. This aspect is mass. Mass times g gives you weight. Density times volume is mass. Mass times acceleration to gravity gives you the weight. So from there, we were able to calculate the volume of water that was displaced, which we got as 0.005 cubic meters. And volume of water displaced, this is, since the entire solid was a mass, this is the volume of the solid, because that body that is submerged is going to displace its own volume. It will displace its own volume. Okay, if I enter into like a bathtub and I'm completely submerged, the water I'm going to displace will give me the volume of my body. Okay, so that was what we actually did, how we were able to calculate the density of the solid. So in our next lesson, we're going to take more calculations. We're going to solve more calculations. So please just watch out for our next lesson. And for this lesson, you might not grasp it the first time. You might need to go over and over again. But I've taken time to really break everything down piece by piece. So just make sure you go over the lesson over and over again. In case you have any question, you can chat me up via WhatsApp. Drop your questions in the comment section and chat me up via WhatsApp on +234 803 829 5185. So like I told you at the beginning, in case you've not subscribed, make sure you subscribe to this channel and hit the like button as well, just to help us, to help our video gain more audience. Hit the like button, drop your comments, and click on the bell icon and set it to all so that you always be notified. I thank you for how you've joined us, and I believe you've actually enjoyed the lesson. So like I said, in the next lesson we're going to treat more calculations on the upthrust and Archimedes principle. Bye for now.